So true, hey? Okay. Okay, so let's go through this one quick. This should, like I said, this will be all review. Okay, so the first one is just how do you know if it's a function? That's your vertical line test. So this would be a yes. This would be a no, no, and a yes. Okay, so we've dealt with those a lot since grade 10. Okay, next. Everything's getting all. Okay, now the parabola is the first. Besides the the line is what gets you going on graphing, but the parabola is the next level that really brings you into finding your max, your min, your your axis of symmetry. Okay, if it's opening upward or opening downward, all these things come into context when you're dealing with these. Now the basic is y equals x squared. The standard form, okay, is, well, this is the nice form to deal with because it really lends to the transformations that we do in 30. And from all of this, we can get the HK that is our vertex. The axis of symmetry will always be the x value. Okay, so x equals h. The max min, or the maximum value will come from the y. So it's either the very bottom y or the very top. Okay, if a is positive, it opens upward, and if a is negative, it opens downward. Okay, so these are things we're going to need to know a lot because as we get going in this stuff and you're drawing graphs, you need to know all the calculus that we've done, but you need to know all of these basics too, right? Now, let's go right to example 2, because example 2 is a full sketch of this graph, again, without using a graphing calculator, but just doing all the algebra properly. So it wants all the key features. It wants the vertex, the max min, the axis of symmetry, and the intercepts, okay? So this is going to cover a lot of review at one time. Now, the first thing that we want to do is we want to find the vertex. And the way we find the vertex is by completing the square. Okay? So, the first thing you always do is you look at the first two terms. And you want to get rid of the coefficient in front of the x squared, but you must factor it out of both of those. So then, y equals negative x squared minus 10x, and then I always leave some space, and then minus 21 is just hanging out there. No, because I factored out a negative. Okay? So, even, you guys, if we just went back to the last one, because I want to illustrate this point again for this last one, I would look at these two, and I would take out a 3. That would be x squared plus 8x. I would leave some space and put plus 20 outside. Okay? So that's always your first step. Again, if you're making a study sheet to have those steps there. Now, does anybody remember how to find those two terms? Because I want to put two terms in here that actually cancel each other out, but they serve a purpose, because when you're completing the square, you're trying to make a nice square in this part. Okay, I want this to be, actually, I want this to be a nice, perfect square. Okay, the way, anyone remember how to find this term? Take negative 10, divide by 2, then square it. Okay? So we will always take this number here, we will divide by 2, then square. So negative 10 divided by 2 is negative 5. Right? Negative 5 squared is plus 25. Okay? And because I can't just go, you just can't add 25 to an equation and not change it. But if you counter that by minusing 25, then I haven't. Okay? Now again, I want that nice perfect square in the brackets, so I have to get that negative 25 out of there. You always want to take into account that number. Now in our case, there's a negative 1 out there. You must take it to get it out of the brackets. You must multiply the two together. So negative 1 times negative 25 boots that out to become 25. So then that would be out of there. Okay? Then I would have y equals negative 1. Now, I'll tell you, if you ever take the middle term, divide by 2, and then square it, that'll always be a perfect square. Okay? In fact, you always know something's a perfect square by, if you look at the first two, or the first and last, they have to be perfect squares. Does that. You have to take the square root of this, and then multiply it by 2. Okay? And its square root of this would be plus or minus. So there's actually two scenarios that would work here, positive 10 or negative 10. But this is a perfect square. So all you have to do now is change this to x minus 5 squared. Okay? These two are identical. X squared minus 10x plus 25 is the same thing as x minus 5 squared. And then you've got that piece on the outside, the 25 and the negative 21 becomes plus 4. Okay, and if you look back to the first page, so right now we have put it in this form right here. H is my x of my vertex, and it's going to be plus k because it's on this side. So these have different opposite rules, right? If you brought it over to the other side, then same rules. But on this side, the h comes after the minus sign, the k comes after the plus sign when it's on this. So keep that straight, because obviously you're going to graph it in the wrong place if you just miss up one little number. So my vertex will be 5, 4. Okay, so that's one thing we know about this. Now, is this graph opening up or opening down? Okay, so because it has a negative 1 equals a, it is opening down. Okay, so it's going to be going like that. Now, what is the axis of symmetry? S5, very good. SYM. X equals 5. Okay, is this going to have a max or a min? Okay, so you want to know if it's opening up or down before you go find your max or min. So the max would be at y equals 4. Okay, now could we graph this at this point? You don't know your x or y intercepts. Okay? So next thing we have to do is find x and y intercepts. Okay? Now, how do you find the y-intercept? Make x equals 0. Okay? So this would be y equals -1 times 0 minus 5 squared plus 4. So y would equal -5 squared plus 4. Yep. Yeah, in fact, the original formula is much faster. Sometimes I just like doing things the hard way. So y equals -21. Okay? But if you put it in right into here, it's really nice because it gets rid of that, and you have -21. Okay? So we got another piece. Now let's do the x-intercept. They're a little bit more work. That we're going to make y equals 0. Okay? Now, I like to use the factored one for this. So 0 equals negative x minus 5 squared plus 4. Okay, let's isolate x. Now, if you put it into the original, it's not that much more work. It's just you would probably want to use, well, this one's not bad either, but you would use the quadratic equation if there was a number in front, because it might not turn out nice. Now this one here, I'm going to get -4 equals negative x minus 5 squared. If I divide that negative out, I will get 4 equals x minus 5 squared. Okay. Now I have to take the square root, right? Now since I'm taking it, make sure it's plus minus. So plus or minus 2 equals x minus 5. So you're going to have to branch off. So 2 equals x minus 5, and -2 equals x minus 5. So you bring that, add the 5 to both sides, you'll get 7 equals x. This one here, add 5, and you get 3 equals x. Okay, so this point here, going back to the y-intercept, this would be 0, -21. Right, that is the point that we're going to graph. The 7, 0 and the 3, 0. Okay, so I kind of left room on the side here. Let's try and graph this. Okay, so first thing, the vertex was 5. 1, 2, 3, 4, 5, and 4, so it's about there. 5, 4. Now, remember we said it's going down, and that's good because I got 2 x-intercepts. If I didn't get 2 x-intercepts, then I'd be very confused right now if I said it was going up. Okay, because if it's going up, I shouldn't get any x-intercepts. So it's going to be going through 3 and 7. It is also going to hit down at -21. Okay, the axis of symmetry is supposed to be going through 5, right? Okay, and I think I can draw my graph now. Okay, it should have a bit of a... Okay, so that's just a huge review in gathering all that information to be able to... Okay, do I need to do that other completing the square, or do you guys remember how to do it? Good. Okay. Okay, so we just want to talk about the basic forms because you really need to have these memorized. In 30-1, you wouldn't have to have it memorized. You put an x cubed into your calculator. Yeah, I know what it looks like now, but you don't get to have a graphing calculator. So remember, x cubed goes like this. And just remember, when all else fails, pick some points and graph it. Pick 1, 2, 3, 4. Pick -1, -2, -3, -4. Okay? Now remember, when you cube negatives, you do get negatives, right? So that's why you can get the negative y's as well as positive y's. Okay? What does a square root x always look like? It always looks like this. Okay? Absolute values always look like this. You will not have any negative y's. Okay, and then what does 1 over x always look like? Well, in this case, you'll have a vertical and horizontal asymptote. Okay, and we're going to talk about, but there's a horizontal asymptote here at y equals 0, and there is a vertical asymptote at x equals 0. Okay, so make sure these are good things to have down on a study sheet or know by now, right? But if you do ever forget, make sure that you're just plotting a few points. Okay. Now, I just want to see if you guys could tell me the equation for this one here. What is the equation of this? What's the first thing that happened? It was flipped. So y equals negative absolute value. Okay, we also moved to the right, so that'd be x minus 3 plus 5. Okay? So that leads into, people right here, leads into the next, and that's transformed functions. Okay? Now, one thing that you always want to keep straight is do SRT, or you could do RST. Right? The thing that has to be common is that transformations are always done last unless you are asked specifically to do it out of that order. Okay, so this A here, on both of these, who's this A belong to? Belongs to the y's, right? So really, and then this is what would happen if there was a horizontal stretch. Okay? So the B must be in brackets, or the B must be out of brackets with the x minus h. And for those of you, again, that took 30, just beware of this, that if you ever see a y minus k, or let's even make it, if you see this, a y minus k equals f b x minus h. Okay? The horizontal stretch and the vertical stretch you'll get right. What you will not get right at this point is that you must always have brackets around here for that K and that H to be correct. So you want to make sure that if you're always taking it out. Okay, so that is the correct form to actually find the horizontal and vertical translation. Okay, and then if you read all through this first, okay, but I think just remember that A and B, there are a stretch. Also, if there's a negative here, it's not a negative stretch. Okay, it's a reflection and then a stretch. There's actually two transformations there. Same with here. If that said negative B, it is not a negative B stretch. Okay, and remember that it's always a reciprocal, right? So we're doing 1 C and D, 2B, and 3 A, B, D, and G. Okay, so if you